45 minutes or less probably. And if I talk fast, even less. I'm not a very fast talker.
Yeah, integrity, sometimes it just depends. Well, usually, when we don't come to class, we just watch, obviously just watch integrity and just fast forward and that makes it quicker.
Yeah, somebody said that she likes to watch it a little faster. You can adjust the speed and watch it faster.
Yeah, I don't do the fastest one. There's no way I could keep up with it. It's too fast.
Oh, okay.
But it's just like one more little click.
Sure.
The fastest one is it's crazy.
Oh yeah, no. Anyway, okay. So direct variation. This is modeling using variation. You'll have to do it this way. Although these kind of problems could be solved using proportions, but you need to follow the way we do it in class here. So, if a situation is described by an equation in the form of y equals kx, where k is a non-zero constant, we say that y varies directly as x, or y is directly proportional to x. And the number k is called the constant of proportionality. Oh, it's fine. I can put this here. Proportionality. Or the constant of variation. So we'll do an example. You're going to write an equation first. This is showing you the steps. You won't have the steps on the test. So the number of gallons of water W used when taking a shower varies directly as the time T in minutes in the shower. So W varies directly as T, so W equals KT is our equation. W equals KT, and we got that from the first sentence. When it says varies directly, we just put a K in front of the second variable there. A shower lasting 5 minutes. So now we're going to use the given value to find K. A shower lasting 5 minutes. So T equals 5 minutes. Uses 30 gallons of water. W equals 30. So we have everything to put into this equation to solve for K. So we put in 30 equals K times 5. We divide by 5 to find what K is. K is 6. Now we're going to substitute the value of K into the equation. So this is our equation. So now I want W equals 6T. This is the general equation for this shower, this particular shower. Okay? Now we have to answer the problem's question, how much water is used in a shower lasting 11 minutes? So now they're telling us that T is 11 and we're using this equation. We want to know what W is. It's 6 times 11 is 66. And it's a word problem, so we probably want to write units. And sometimes a sentence. Yeah, it's fine. Okay. We could write a sentence. Okay. Now, I know there's other ways to solve this, and you can solve it another way, but you won't get full credit. If you solve it, so you have to solve it this way to get full credit. It's just practice in different ways of solving things to get you ready for calculus. All right. Next one. A height. And here's another example. The height that a ball bounces. So we're going to let that variable be b. Varies directly equals k. As the height from which it was dropped, we're going to let that be d. So our equation is b equals k times d. Now it gives you, for a tennis ball that's dropped from 12 inches, so our drop height is 12 inches, bounces 8.4 inches. So we're going to plug those in, solve for k. 8.4 equals k times 12 divided by 12. 8.4 divided by 12. .4 divided by 12. So k is 0.7. So now in this is our equation. We fill in, we want b and d to be variables again. We write it, we fill in k. Now we're going to answer the question. It says, from what height was the tennis ball dropped if it bounces 56 inches? So we're given b is 56 now. What's the drop height? So 56 equals 0.7 d divided by 0.7. 56 divided by 0.7 is 80. 80 is the drop height. So the ball was dropped here. I'm giving a good example of writing it out in terms of what it means. Dropped from 80 inches, or a height of 80 inches. And that's the first page. So this section is pretty easy here. Is anybody still writing? All right. So that was direct variation. Y equals kx. And that's on your formula sheet. Probably ought to print out your formula sheet and practice using it. Practice just using your formula sheet. Inverse variation. So if a situation is described by an equation in the form y equals k divided by x, where k is a non-zero constant, we say that y varies inversely as x, or y is inversely proportional to x. The number k, again, is called what we said before, either the constant of proportionality or the constant of variation. Okay, a note here. K is in the numerator. We're just making a note of that. K, if you made the other one a fraction, K is in the numerator over there too. So, all right, so let's do a couple examples of this. The length of a violin string, so let's make that be L, varies inversely, equals K divided by the frequency F of its vibrations. So there's our general equation. L equals K divided by F. Now it's going to give you two values. A violin string 8 inches long. So L is 8, vibrates at a frequency of 640 cycles per second. So we fill in that and find K. 8 equals K divided by 640, multiply by 640. K is 640 times 8. So K is 5,120. Okay, now we write our equation, but with L and F back to variables, and K is going to be filled in. So for this violin, L is 5,120 divided by the frequency. Now we answer the question, what is the frequency of a 10-inch string? So now we're given that L is 10, we want to know the frequency. So fill in that 10 equals 5120 over the frequency. So we can multiply, we can make this a fraction, multiply by F to cancel, to get the F in the numerator, or we could have cross multiplied, we get the same thing. We get 10F equals 5120, divide by 10, F is 512. And that's in cycles per second. Okay, are you following this? Everybody following? Any questions? All right. Radiation machines used to treat tumors produce an intensity of radiation, capital I, that varies inversely, equals K over as the square of the distance from the machine, as D squared. So our equation is I equals K over D squared, because it said inversely. At 3 meters, so now it's telling us that the distance is 3, the radiation intensity is 62.5 millirentron, whatever, MR per hour. Okay. MR per hour, apparently. Don't ask me to pronounce that. I know, we can go around the room and see if everybody can pronounce it. Millirentgens, whatever. Okay. Okay. So we have everything but K, we fill that in, 62.5 equals K divided by 3 squared, that's 62.5 equals K divided by 9, multiply both sides by 9, that's what K will be equal to. So 9 times 62.5 562.5. So K is that. Get rid of the calculator, we're done with it for now. We'll use it later. Okay, so next step, rewrite your equation with K filled in, and for this machine we're gonna have an intensity and a d squared. So I equals 562.5 divided by d squared. Now it says, what is the intensity at a distance of 2.5 meters? So d equals 2.5. What is I? So I is going to be 562.5 divided by 2.5 squared. We need to put that in the calculator. I can just hit divided by 2.5 squared. Is it going to do the right order of operation? It has to square the 2.5 and then divide. Yes, the calculator will square before it divides. I didn't need the extra parentheses, but, and you can check, you can do 2.5 squared, and then you can take 562.5 divided by 6.25. Yeah, so, the calculator will do the right order of operations as long as you tell it the right way. And that's 90, and that's MR per hour. And we're done with page 2, see? The last page, combined variation. We're just going to get rid of our calculator here for a minute. So, I told you, so direct variation was y equals, and I'm going to write k1x. Inverse was y equals, let's write k2 over z. We're going to change the variable. So in combined variation, direct, like that, and indirect or inverse, variation occur at the same time. So our equation is going to look like this. Y equals K1 times K2 times X over Z. That's a Z, not a 2. I make a line through my Z's. But you don't need a constant. Two constants multiplied together will just give you a constant K. It's just, you're only going to write one constant. So you're going to write it like that. You don't need two constants. When you multiply two constants, you're going to get another constant. So you don't need two constants. So that's the equation for combined. This one right here. Y equals kx over z. Joint variation is a variation in which a variable varies directly, and we sort of directly as a product of two or more other variables. So this, for joint variation, it's directly, so it's y equals k, and then it'll be, x times z. And you could even have a squared up here or something, or cubed. If you can continue, you can have it times w times whatever. Okay, but that's joint variation. So here's an example of combined variation right here. And I just love this question. One's intelligence quotient, or IQ, so we're going to use IQ, varies directly equals K as a person's mental age, let's call it M, and inversely divided by that person's chronological age, C. So inversely, we put the variable in the denominator. K stays in the numerator. We only need one K. So that's our equation. Our next step, it gives us a person with a mental age of 25. So M equals 25, and a chronological age of 20 has an IQ of 125. It gives us all these variables except K. So we're going to plug those in and solve for K. 125 equals K times 25 divided by 20. You can take the 20, I know I can divide by 5 very easily, but 25 divided by 20, and I'm just showing you can do math to fraction, you know, if you're bad at reducing fractions. But you could divide this by 5 and you get 5, and this by 5 and you get 4. And the simplest way to, you're multiplying K by a fraction, is to multiply by the reciprocal on both sides. That's going to cancel those. This is times 4/5. And so those cancel, and you're left with K on the right. And then you take 5 into 125, and you can do it on your calculator if you want. But that's 5 into 125, 25 cents? Yeah. And 4 times 25 is 100. But you can use your calculator for some of those calculations there that I just did, sort of. So K is 100. So now we're going to write this equation with K replaced. So IQ is going to be 100 times the mental age divided by the chronological age. So what is the chronological age of a person with a mental age of 40? So now it's telling us they have a mental age of 40 and an IQ of 80. And in my fast-paced class, somebody said, 80? Wow, that's pretty low. And I'm not sure our IQ actually falls as we age like this so much, but I don't know. I take exception to that. But as long as you're still exercising your brain, your IQ's not going to be falling like that. I don't know if is that what it means? The older we are, the lower our IQ? But I don't know. But anyway, you fill in, so now what's the C? We want C. So we fill in these. 80 equals 100 times, this is what, I don't like this problem. I think it's kind of nonsense, but. And that's 4,000 divided by C is 80 over 1. You could either cross multiply or you could multiply by C. Those cancel. It's the same as cross multiplying. 80C equals 4,000. So now you need to divide by 80. And I ran out of room. So I'll write it right here, 80C divided by 80 equals 4,000 divided by 80. That's 50, right?
Yeah.
And that's your answer. But anyway, I looked in our book, and the only combined variation problem they had was this IQ one, because I wanted to change from this problem. So, but anyway, that's a combined variation. So these problems all work the same way. Anyway, so this next one is joint variation. Did you finish writing? This is joint variation. The force of wind on a window, with these winter storms, maybe we'll know about that. So the force F of the wind on a flat surface positioned at a right angle to the direction of the wind varies jointly. That means it's going to be y equals kxc or whatever. Varies jointly. So force F varies jointly, so that's a directly equals k something with the area A of the surface and the square of the speed v of the wind, v squared. Okay, so that was from the first sentence. They told you what variables to use. Then it tells you everything but k. So a wind of 30 miles per hour. So if v is 30, blowing on a window measuring 4 feet. So the area is 4 feet by 5 feet. It's 20. Has a force of 150 pounds, and I was being kind of 30 miles per hour. I was leaving the units off. I don't think science people will like me right now, but leaving the units off. Okay, so force is 150. We're leaving the units off. We're just assuming they're right. K, the area is 20 and 30 is squared. We have to square the 30 first. That's 900. So we get 18, 1, 2, 3 zeros. Yeah. 2 times 9 is 18, and then we have 1, 2, 3 zeros. And that's 150. Okay. Okay. And then we divide by 18,000, I mean. And so 150 divided by 18,000. And it didn't tell you this, but we're going to round k to 4 places. So k is approximately 0.0083. And math, enter, k actually equals 1 over 120. So I can even show you what's the difference if we round to 4 places or if we use 1 over 120. And if I give you a test problem like this, I'd have to tell you how much to round k to. If I don't, you ask during the test. Okay. And then the next thing, we found k. We're going to use to 4 decimal places. So we're going to fill it in the equation. F equals 0.0083 A velocity squared. Now that's our general equation. Now it says what is the force on a window measuring 3 by 4 feet? So now we've got a new area. I'll write it over here. 3 times 4 caused by a wind of 50 miles per hour. And we're leaving the units off. Okay. So this is 12. So we're going to find the force. So force is 0.0083 times 12 times 50 squared. And we're just going to do that in our calculator. So 0.0083 times 12 times 50 squared. And it's going to do this 50 squared first, and then it's going to multiply. The calculator knows the right order of operation. And we get a force of 249 pounds. So what would be the difference if we use the exact value of K, 1 over 20? 1 over 120 times 12 times 50 squared. If we exact value. So we usually do round. Let me show you what that is. 1 divided by 120 times 12 times 50 squared. So the exact value is 250. So we're off by 1. So we usually round. But we'd be off by more if we rounded just to 3 places. We would, or rounding to 2 would be even more be off. So because we went to 4 places, we were pretty close. That's it. So try to do the review before class, and then I can help you with the ones you didn't understand. But it's posted in Show Me. Do your math lab and all that. Thank you guys.